Hello viewers, welcome to the second lecture of Control System video series for GATE and UGC-NET. The topic of today's lecture is Properties of Laplace and Inverse Laplace Transform. I am Akshay Juneja. To know more about me, you can click on the link given in the description box below. So without wasting any time, I will start with the contents of this video lecture. We will discuss the definition of Laplace and inverse Laplace transform. Then we will discuss eigenvalue and eigenfunction. Then we will discuss some theorems. Coming to the definition part, what we have is Laplace transform and inverse Laplace transform. So as we can see here, xt is a function in time domain and xs, capital Xs is the Laplace transform of the xt function in S domain, right? It is given as xt e raised to minus st dt. The limits are minus infinity or 0 to plus infinity, and lower limit is 0 for unilateral system and minus infinity for bilateral system. Now what is a unilateral system or a bilateral system? You will learn about these when you will study mathematics or signal and system part for your exams. Now what is S? S is the sigma plus j omega, where sigma is damping factor and omega is oscillation frequency, right? Here is the a simple representation of S. Sigma is for x-axis and j omega is for y-axis. Now what is inverse Laplace transform? It is given as the L inverse of xs, which is xt, right, is equal to 1 upon 2 pi j integration of xs e raised to plus st ds. The limits are c minus j omega to c plus j omega. Now coming to the eigenvalue and eigenfunction. Eigenvalue is system input and eigenfunction is the amplitude factor or constant. So system output is given as system input into constant, like yt is a function or output of the system, which is equal to ht convolution xt. Remember that this star is not multiplication. It means convolution in time domain. So taking Laplace transform on both the sides, we get ys is equal to hs into xs. Now this is multiplication. Coming to the theorem part, we have initial value theorem. Since the here we are referring to the initial value, so t will tend to 0, right? And if t will tend to 0, s will tend to infinity. So limit t tend to 0 for ft is equal to limit s tend to infinity s into fs. Remember that this theorem is only valid if the greatest power of a variable in numerator is greater than the greatest power of the same variable in denominator. If numerator is x raised to 7, denominator is x raised to 5, then it is valid. And if suppose in numerator we have x raised to 4 and denominator we have x raised to 6, then this theorem will not be valid. Coming to the final value theorem, so limit t tends to infinity for f of t is equal to limit s tend to 0 s of fs. As we have discussed already that time and s domain will move in opposite direction. So this theorem is not valid if roots of denominator lie on the RHS of the j omega axis. Now what is RHS? It is the right hand side of j omega axis, which we the graph we have seen in the previous slides, right? So that is it for today, guys. I will I hope that you understand this lecture, and please like, share, and subscribe the channel. Thank you so much.